Okay, so we're going to go on to question 15, and we're going to start by resolving all of our forces parallel and perpendicular to the plane. So I'm going to start by doing that with the force x newtons. So that's going to be pushing down into the plane, and it's going to be pushing also parallel up the plane, and that's going to be with an angle theta. So I've got my right angle there, so this black line here going into the plane is going to be x sine theta, and parallel to the plane I'm going to have x cos theta. Okay, we're now going to do the same thing to the weight. So there's a mass of 2, so there's a weight downwards of 2g. And again, I'm going to resolve that into perpendicular to the plane and parallel to the plane. And again, there's my angle theta. So here, perpendicular to the plane, I'm going to have 2g cos theta. Notice this is right even though I've got a perpendicular plane involving sine and a perpendicular to the plane involving cos. That is correct because the angle here is the effect on the horizontal force, whereas here it's an effect on the downward force. And then here I'm going to have 2g sine theta. The other forces that are going to operate on this are going to be my reaction force, which is going to operate perpendicular to the plane, and we also know that it is accelerating up the plane, so the friction must be acting downwards parallel to the plane. So I'm going to have friction force here, which I'm going to put just with the left arrow just so that we're not confused. Here it's going to be acting downwards, and we know the coefficient of friction is 1/2, so we're going to just put that as 0.5 r. And let's just remind ourselves that this is going accelerating up the plane at a equals 1.45. Okay, so what I'm now going to do is I've got a lot involving sine theta and cos theta. I've been given tan theta, so I just want to work out what sine theta and cos theta are, which I'm going to do over here. You should be fairly familiar with this by now. Here's my theta. My opposite is 3. My adjacent is 4. Standard Pythagorean triple, so this must be 5. And now it tells me that sine theta is going to be 3/5 and cos theta is going to be 4/5. And we can start forming equations with our forces on the diagram. So we're going to start by resolving everything perpendicular to the plane. Remember, there is no acceleration perpendicular to the plane, there's only acceleration up the plane. So all my black forces here, my reaction force, the perpendicular component of the weight and the perpendicular component of the pushing force should equal to 0. So if I resolve, I'm going to resolve outwards from the plane, it tells me that r equals x sine theta, or x times by sine theta. Sine theta is opposite over hypotenuse, so it's x times by 3/5, plus my downward force, which is 2g, times cos theta, which is 4/5. So I can say that r equals, let's give it as a decimal, make it nice and easy on ourselves, 0.6 x plus, that's going to be 0.8 times 2 plus 1.6 g. And that's going to really help us when we come to our resolving horizontally, resolving parallel to the plane. So we're now going to move to resolving parallel to the plane. And now we need to be a bit careful here because I can't equate my forces because we know they're not equal to each other. It's just that the total of the parallel forces is going to give me my mass times acceleration. So if I'm going upwards, I've got x times by cos theta. Cos theta is my adjacent over hypotenuse, so x times by 4/5 minus, all my forces were directing down the plane, minus 0.5 lots of r x plus 1.6 g and that minus 2g times sine theta times by 3/5 must equal my mass, which is 2 kilograms, times by my acceleration, times by 1.45. Okay, so I've got 4/5 is 0.8, so I've got 0.8 x, a half of 0.6 x minus 0.3 x minus 0.8 g. Now this is going to be 0.6 minus 1.2 g equals 2.9. Well, that gives me 0.5x minus 2g equals 2.9. 0.5x minus 19.6 equals 2.9. So 0.5x equals 2.9 plus 19.6, which is 22.5, and x equals 45 newtons.